Welcome. Together, we will go through the latest improvements in Fatigue version 2025.1. So, what's new in Fatigue? Regarding the calculation methods, we support multi-axial fatigue, thermal fatigue, and damping in modal response. We have established a run scheme based on file name and location. In materials, it is possible to define a double-slope SN curve. What's more, regarding post-processing, we provide the annotations tool. Let's start with the new calculation methods. Several critical plane fatigue life estimation models have been suggested. The models can be divided between stress-based and strain-based. For stress-based multi-axial fatigue, we support Findley model. For strain-based multi-axial fatigue, we support Fatemi-Saucier and Smith-Watson-Topper models. Also, the material cards have been enhanced with the respective parameters. Let's take a look at the newly added fields regarding multi-axial analysis. Access the material database. Define the general properties of the material. After, move to the desired tab, SN or EN, and define the desired uniaxial and multiaxial properties. Assign the material to the desired PID. In the Analysis Configurator window, select between stress or strain-based analysis. Define the input results and the multiaxial model. Calculation type is critical plane. The rest of the process is as usual. Moving on with the presentation, we have the definition of materials used for thermal fatigue. Different SN or EN curves can be defined per temperature. Chebosh model is also supported. Thermal fatigue is supported for both SN and EN analyses. The input results can be pseudo-static, with constant temperature or time-dependent temperature. They can be of type load blocks, where the temperature can be constant or defined by the maximum, minimum, or the mean temperatures of the respective peak and valley. There is also the possibility to read temperature from file. For transient analyses, the stress and thermal results are read from the file. Let's take a look at the newly added fields regarding thermal analysis. Access the material database and define the desired parameters for a temperature-dependent material. Switch to Assign Materials and set the material to the desired PID. In the Analysis Configurator window, select between stress and strain-based thermal analysis. Then, define the rest of the parameters. This example has load blocks as input results. In the Loads window, define the loading which is of type load blocks. In the Properties area, set the repeats and select the desired option for temperature. The rest of the process is as usual. Then, we have included the damping in modal response. It can be found in the Modal Response window. There, the damping parameters can be set to be taken into consideration. It is applied in time and frequency domain for the cases of modal stresses and modal displacements. Regarding the run management, it has been completely refactored. The model must be saved prior to running the analysis, so that an output directory is specified. The output files will be saved in the same directory as the project, and the names of the files produced upon the solution are dependent on the given project name. If we rerun Analysis 1, the files can be overwritten or created again with the same name plus the postfix run 2. An SN curve with two slopes can be defined in the respective tab of Materials window. Moreover, we have enhanced our post-processing capabilities with effortless creation and management of annotations on points of interest. Now, annotations can be created based on entities, from filter and on min-max. In the Annotations section of the Post ribbon tab, define annotations in 3D or 2D windows. The handling of the annotations can be done through the Annotations list. In this version, the documentation is also enhanced. Information regarding some new features can be found in User Manual as the thermal fatigue example. In Theory Manual, there is a chapter dedicated to multi-axial fatigue. Furthermore, among many others, some new features that are already under development are weld analysis calculation according to guidelines, material generator, global units, reporting tool, and further speed improvements. Thank you for your attention.